This question is about some area ratio. And there are two common techniques. The first one is if we find two triangles share the same height. Then the length ratio, like 3 to 2. Length ratio is equal to area ratio in this case. But however, another case is talking about two similar triangles. Most probably is formed by a parallel lines, and then we find the first triangle similar to the bigger triangle. Then L1 to L2 is not the same as A1 to A2, but their area ratio is equal to L1 square to L2 square. Two-dimension extend, then the area ratio will be square also. But just one dimension expand, then their only difference length ratio will become their area ratio. Go back to this question. They say AP to PD is 3 to 2, which means that this is 3K, then this one will be 2K. K is a multiplier because the length is not exactly 3, maybe others. And then we are going to use the property of parallelogram. This sine is equal to this sine. So we also know that this is 5K. After that, they say that triangle DEP. Triangle DEP, the area is 4 cm square. Usually the area, I will circle it to identify the difference between the length and also the area. We are going to find out the area of trapezium ABCP. That's our target. Before that, we find out their similar triangle. A small triangle and then similar to the bigger triangle from E to B to C. And then we know this is 2K while this one is 5K. So the length ratio, we already know that. That means if this is another length 2L, then this will become 5L. So this section 2L, then another section we become the difference 5 deduct 2, 3L. And then after that, we focus in two triangles, the first triangle and the second triangle. Why I consider this is because they share the same height here. With the same height, one dimension are the same, then the another dimension ratio is the area ratio. So this area to this area is also 3 to 2. A1 to A2 is equal to 2 to 3. That means 4 to 6. So if this is 4, then this area will become 6 cm square. After that, I focus in some other different triangles. For example, this time I focus in this triangle and also this triangle. Again, these two triangles share the same height. And then, which means that the length ratio 2 to 3, the base ratio is equal to area ratio. Again, 2 to 3, and I want to create 6, of course it's 9. And then so this one is 9 cm square. After that, this time maybe I consider this triangle and this triangle. They also share the same height, but one of the base is upper, one of the base is lower, no difference at all. So their area ratio is 3 to 5. 3 to 5, and then one of them is 9. So, and 5 times 3, we get 15. So this part of area is 15 cm square. The question asks about the area of trapezium ABCP. So you just add these two areas together, you get the answer A. I want to emphasize that if you use the same logic, there are many different procedures. Maybe you consider two different triangles, but finally the conclusion should be the same. There is no fixed flow of this kind of question.